In this video we're going to show you all the basic steps for cutting a part in the software. We're going to start by setting up our job, then we're going to import some vector data that's been created in another design system. I'm going to show you how to locate that in the material, then double check your material setup so that it matches that you're going to have on your CNC, and calculate a profile toolpath in order to cut the part out. In this case we're going to use tabs to hold the part in place that you can see on the screen here. Before we save that toolpath, we're going to use the excellent preview function the software has so that we can verify the part looks as we want it to when we machine it. When we're confident that that looks right, we'll show you how to save the file in a format that your machine tool will be able to understand, and then you'll be able to take that over and cut the part that you've seen us create here. This is a longer version of this tutorial where we explain in detail each of the steps. There is a shorter version of this where we run through the process much more in real time so you can see just how quick and easy this would be. To start here, let's open a new copy of the software. So we'll start by defining our work area. So I'm going to come up and click on the icon to create a new file. And in here I'm going to define my piece of material, or at least the area on that material that I plan to cut within. You obviously have to be aware of work holding, clamps, screw down, things like that, and make sure you take that into account when setting this up. For our job I'm going to set up a width, or the X value if you want to think of it another way, is going to be 8 inches, and then the height of our material, or the Y value, is going to be 2 inches. Next we're going to set our material Z0 position. So here I'm going to work off the top of the block, and this is just something I need to make sure that I replicate when I set up my CNC. Next we tell the software the thickness of our material. In this case we're using 1/8 inch thick material, so I'm going to type that value in there. And next we tell it where the XY0 position is going to be. This also is important to reference in the same place when you do your CNC setup. Here it's currently set to the center of the material, and that's indicated in the 2D view by the lines here and the red square you can see there. In this case I would like to change that so the lower left hand corner is our XY0 position, or the datum, which is another word for that, and now we can see that's updated in the 2D view. I now want to work in inches, so that option's checked there, and we can go ahead and hit OK, and that will create our workspace and put us into the main interface of the software. So the data for the part we're going to cut was created in another drawing program, so we're going to come up to the icon here to import vectors from a file, and we're going to load a file called WingSpar.dxf. So I'm going to select that from the project folder and hit open. Now as I say, this data was created in another software program, and we can see that it's in a slightly strange location relative to how we've set our part up, and that's because it will automatically be placed wherever it was drawn. So whatever coordinates it was drawn in the original design system, that's where it will appear when we import it into our software. So our first job is to take that and position it into our work area. By default these vectors will automatically be selected when we first import them. So if the first thing we do is to come over to the icon here and click on Align Selected Objects, and then to click on the one in the middle at the top here, then that will align our selected objects both horizontally and vertically in the middle of our work area, which is exactly what we want to do in this case. Let's come down now and hit close. And at this stage we have no further edits to make. We just want to cut these vectors that we've imported. So our design's complete. We can come up and click on the icon here, and what that will do when we click it is minimize the design tab on the left, so you can see that's closed now, and on the right it's opened our toolpaths tab, so we have access to set up our material and to choose the type of toolpath we'd like to cut this shape with. Now as I mentioned there, the first thing that we ever want to do before we calculate any toolpaths is to check our material setup. And this is so important because it's what references the job in the computer to the actual part on the machine. To do this we can come over to the material setup area in the toolpaths part of the interface, and we can get a quick visual check of what our current setup is if we want to have a look at that and continue. Typically it's safer to hit the set button here and have a really good check of your material to make sure that the parameters are what you want for this particular part. So here I'm going to double check some of the things that we've already set up when we first created our new job, and that is that Z0 for the materials on the top of the job, our material thickness is 1/8 of an inch, our XY0 position is in the lower left hand corner, and here I can also see something called the rapid Z gaps and the home position. The rapid height is the distance above the material that the part will, or the tool rather, will retract to so that it can move quickly to another area of a toolpath. So it's important that these values are high enough that the tool can clear any clamping or hold down that you may have on the job. The home position is just a location that the tool is going to go to before it actually starts a toolpath. So in this case, the tool will move to X0, Y0 and a position 1/2 an inch above the material before it does the cut. If we're happy with these values, then we can hit the OK button, and now we're ready to choose the type of toolpath that we'd like to have operate on the vectors that we've got selected here. In this case, we just want to cut the part out, so we're going to use a simple profile toolpath. Now it's important we select the objects that we want to cut. At the moment, I still have my vectors selected in the 2D view, but if I click anywhere in the background there, you can see they become deselected. Now, when you need to choose vectors, there's a couple of ways to do it. I can either click and then hold the Shift key down to add to that selection there, as you can see there, or I can click and completely enclose the objects if I drag from left to right, or I can click and just partially enclose the objects if I drag up from right to left. So whatever way you want to do it, make sure the objects you want to cut are selected. Now I can come over and click in the icon here, which is the profile toolpath icon. Now in this case, I just want a very simple toolpath. So the first thing I'm going to do is just uncheck this Show Advanced Toolpath Options there. So now I get a simpler form to work through. If you want some of the more advanced options, you just check that and they'll reappear. So the first two values that I need to tell the software are the start depth of the toolpath and the end depth or the cut depth. So we're going to start at 0 on the top of the material, so that is correct. The cut depth, I just want to go to the depth of my actual material itself. So in this case, that is 0.125 of an inch or 1/8 of an inch. Next, I need to tell the software what tool I want to use to machine this. Now at the moment, we have an 1/8 inch end mill selected from the tool database, and that is the correct tool, but just to show you the way that you would select a new tool here, let's click on the select button. This will open what we call the tool database, and this is essentially where we keep our library of tools. Now this is fully configurable, so you can add tools to this, you can make edits to the tools in here, and you can get a set that works for the typical type of applications that you do, the tools that you own, and the materials that you'd like to cut. Here, as I say, we're going to select this 1/8 end mill, so from the end mill section under Imperial Tools, I'm going to select the 0.125 inch end mill, apply and hit OK. Now if I want to, I can make changes to the parameters for that toolpath just for this particular job, and to do that I would hit the edit button here, and now I can change any of the values if I wanted to, so that they would be machined differently for this particular toolpath alone. That wouldn't make any or wouldn't have any effect on the settings I've got in the tool database next time I select this tool. So if we wanted to, perhaps we might change something like the spindle speed, the feed rate, or the pass depth there, and that would control how many depths of cut we get to cut the part out. In this case, I'll just change the spindle speed and hit OK. Now it's worth noting at this point that if you do plan to actually machine this job, then it's very important that you use settings for the material and that you calculate all the toolpaths using parameters that are safe and appropriate for your particular machine, the tooling that you have, and the material that you plan to cut. So with the tool selected, we come down to the next section of the form here, and that's where we tell the software whether we want to cut outside the vectors, inside the vectors, or to put the tool directly onto the vector, so the center of the tool on these lines. In this case, the vectors represent the outline of the part, so I want to cut outside these vectors. Now the software automatically knows that if it's cut outside this first one, that when it encounters another vector that's completely enclosed within this, then it actually needs to move to cutting inside, because in effect that is going to be the outside of my part when we cut these pieces out the middle of our wing spar. If there were more nested pieces within here, so if this had shapes within shapes within shapes, then it would know to keep alternating the side that it was going to cut on so that I would end up with the correct piece. The next option in here is whether we climb or conventional cut. In this case we'll just choose climb. Then we can decide if we want to ramp into the job. What this will do is come in at a diagonal rather than vertically down as it's entering the material. In particularly hard material or with some tooling, this can just help to lessen how hard the tool is used really, so it might reduce the wear on the tool. In this case, let's just set that so we can see what it looks like. Now enter a value of a 1/2 inch ramp. Lastly here I've got the option to add tabs to the toolpath. What tabs do is allow me to keep the object we're cutting attached to our original piece of material. Now whether you use these will depend on what type of hold down you have. If you have a vacuum hold down, you may not need to tab the object. If you're taping the part down, you may not need to use tabs. In this case I'm going to assume that I don't have a good way to hold it down other than to keep it attached to the original piece of stock, so I'm going to check the option to add tabs. The length of tabs I'm going to create is going to be 0.15, and the thickness of these tabs I'm going to set to be 0.1. Now we need to place these, so I'm going to click on the button to edit tabs and have a choice here of either choosing a distance between tabs or putting in a constant number. So maybe we'd choose that we want 4 tabs and click on the button to add tabs there, and you can see what it's done is it added 4 tabs to all shapes. Now for these internal pieces I just need to hold those in place, so I probably don't need 4 tabs on those. If I want to remove a tab, I just come over and click on it and the software will take it out. So I'm just going to take off some of these extra tabs here, so we've just got a couple holding the part in place in the middle. Maybe we would use 4 tabs on the outside, but perhaps I'd want to change the location of them, in which case I can just move the cursor over them, click and drag that in order to relocate it into a new position on the job. When I'm happy with my tab placement and the number of tabs, I can hit close on the tab selection form, and at this stage the only thing left for me to do before I calculate this toolpath is to give it a name. So I'm going to call this profile cutout, and I'm also going to put in some information there that helps me recognize what tool I've used. Now the name I give a toolpath is completely up to me, and you just want to come up with a method that works for you so that you can get as much information as you can from looking at the toolpath name. If we hit calculate now, the software will take all the parameters that we've entered, and as soon as the toolpath's finished calculating, it will open the 3D view automatically, which is what we can see in the main part of the screen, and also the preview toolpaths form over on the right. The 3D view is our virtual piece of material. I can rotate this around, I can click on the icons at the top here to adjust where that view appears, and I say if I click in the window I can rotate that and look at the toolpath we've created to cut out our WingSpar part. Let's just click on the ISO view there to fix that at an angle. So within the 3D view, after we've calculated a toolpath, we do get this visual representation of the path that the tool is going to follow on the CNC. There's various color coding to show you the different types of moves being made. The red indicates that it's a rapid move getting from position to position above the material. The light blue is it plunging into the part, so here it's showing you ramping down to get to the toolpath depth. Green is where it's retracting out, and the dark blue is its actual cutting move, so this is where it's moving in the material at the feed rate that we've specified for the tool. Now looking at this is quite useful, but it doesn't really tell us exactly what the part will look like when we've cut it, and that's where the preview function comes in. And this is a very powerful function in the software that lets us get a virtual animation of how the tool will cut and what the finished part will look like once we machine it. Within the preview form we can choose the material that represents our part, so let's choose cherry from the list here, and we can see that change the material there. I'm going to choose just material color. I don't want to color the area for the toolpath in this case, but I am going to animate the preview and draw the tool, although this is such a quick toolpath we'll barely have a chance to see those happening. Now we can click Preview Selected Toolpath, and if you look at the 3D view when I do this, you'll see that it just very quickly animates that tool moving through the material. I can use the slider here to slow that down if I want to before I hit the preview button. Now we can see an actual virtual representation of what our finished part will look like, including the tabs that are going to hold the part in place and the actual shape of the job, whether we've cut through the material or not, and how big the radii are that we're leaving based on the size of the tool. All this allows us to look at the job and see if it's going to cut correctly or not. If it isn't, then we need to make changes to the vectors, the tool, or other choices that we've made when setting up the toolpaths. If we are confident that this looks right, then at this stage we're ready to actually save this toolpath out to our CNC machine. To do that, we're going to close the Preview Toolpaths form, make sure the toolpath's selected in the list, which in this case it will be because we only have one toolpath. Then we're going to click on the icon here to save the toolpath. Just uncheck the option at the top if that's checked there, because we want to save the selected toolpath. So now we can see that in the list of toolpaths to be saved here. And what we need to do next is choose the post processor. If we click on the down arrow here, you can see we get a large list of choices that are available to us. I'm just going to choose the G-code inch option there. And what this post processor is going to do is convert the information within the software into a language my machine understands. So you need to choose the post processor that's appropriate for your particular machine or the control software that you're using to drive it. Once we've chosen the right post processor, we'd just click on the Save Toolpaths button, we'd give the file a name and we'd hit save, and that would be the file that we'd then move across a network or put onto a memory drive in order to transfer it to our machine tools control so we can send it to the CNC and actually cut the part that you've seen on the screen here. In this case, I'm not going to save the finished file, so we'll just hit cancel and we'll hit close on the Save Toolpaths form. So that gives you a quick look at the complete process of setting up a job, importing the data you want to cut, checking the material setup matches that you're going to cut on your machine, and then calculating a toolpath using the tool that you're going to choose and load into your CNC and appropriate parameters for that, previewing it to make sure it looks correct, and then finally saving that out with the appropriate post processor so that you can cut the part that you've seen in the software. The last stage is just making sure you set up your CNC in the same way you've told the software that you're going to, so matching the XY0, the Z0, and putting in the correct tool. Last thing I want to do here though is save a copy of this file so that if we wanted to, we could make edits to it at a later date. To do that, I'm going to come up to File, Save As, and in the project folder here, I'm just going to call this file WingSpar Toolpath, and that will be given a .crv extension, which is the standard file format that we've got in the software. Now at any time I could reload that and make changes to it if I wanted to machine another one, or perhaps make multiple copies, or make any edits to the toolpath we'd created. That concludes this video tutorial. There is a shorter version of this where there's less explanation about the different stages so that you can see just how fast this process would be if you weren't pausing at each stage to make sure you had a full understanding of it.